everyone. Up next, we have Wendy Grus, who's going to give her talk, When is it good to be bad? Web Scraping and Data Analysis of NHL Penalties.
Great, so how many of y'all are here because you're hockey fans? Whoa, okay, that's awesome. How many of you are here because you're interested in web scraping? Oh, who knew there was such an overlap? Okay, so hopefully there'll be something for everyone in my talk. My name is Wendy Grus. I'm a data analyst at INRIX, which is a transportation data company in Kirkland, Washington. So I look at data all day long, and I pretty much love it. I'm an organizer of Seattle PyLadies, which is an awesome organization. I get to meet women who code in Python, people who are just starting to people who are professional developers, and it's so much fun to be able to interact with all of them. And one of the things I find from interacting with people on the newer end of the spectrum is that they're really interested in what kind of projects they can do, especially web scraping, but they just don't know where to start. They're like, what can I do for web scraping? And so today I'm going to give kind of an approach to your first web scraping project and show how you can use one of your own personal interests to sort of drive that project. So one of my personal interests is hockey, and so I'm going to use examples from web scraping NHL hockey penalties as to show you how you can do web scraping. So I have a little bit of hockey background for those of you who don't know much about hockey, and then we'll get into the web scraping part. So in January of 2015, Zac Rinaldo, who's a forward on the Philadelphia Flyers, he got a penalty for boarding Kris Letang of the Pittsburgh Penguins. So boarding is a kind of dirty penalty where you slam the guy into the boards when he's not looking, and it can cause a lot of injury. So I'll just quickly show you the video. Hopefully it works. So the penalty is going to happen in like the middle top of the screen, and then they'll show it again. So there, you see Kris Letang go to the ice, and then they're going to slow it down and zoom it in. So you can see Zac Rinaldo is actually jumping off the ice into an unsuspecting Kris Letang, who then falls to the ice. So Zac Rinaldo gets ejected from the game, and then after the game, he says, I changed the whole game, man. Who knows what the game would have been like if I didn't do what I did? And so this was really interesting. Zac Rinaldo was saying, in essence, he did really good by hurting this other player. And Zac Rinaldo got suspended for 8 games for this hit. And so here's some hockey basics. So there's 5 skaters on the ice most of the time, plus a goalie for each side. But then when you break certain rules, so you get a penalty like that boarding penalty, or you trip another person, or you elbow someone, or like you hook them with your stick, then you have to go to the penalty box, and your team has to play a player down. And so your team only has 4 skaters at that point, whereas the other team has 5 skaters. So this seems like it always puts your team at a disadvantage. But as Zac Rinaldo suggested, can taking these penalties ever help your team win the game? So this seems like kind of a silly question since you're always going to be playing down a player. So why would Zac Rinaldo propose this? And the reason he proposed this is very much job security. So there's a lot of different types of players in the league, and they kind of run this gamut of skilled players to enforcers. Skilled players are the guys who score all the goals or keep all the goals from getting scored. Enforcers are the guys who are out there to cause trouble and agitate the other team's skilled players and keep them from scoring all the goals. And Zac Rinaldo lies very much on the enforcer end of the spectrum. So he needs it to be good for him to go out there and agitate and cause other players to not be able to do their job effectively. And so there's a couple different ways we can look at how, at what type of player or person. So I've just pulled out two two stats for players that sort of show the difference between enforcers and skilled guys. So in the red and the pink, you see the skilled forwards and defensemen. So they have high time on ice per game and a low penalty in minutes per game, whereas the enforcers have a higher penalty in minutes per game and a lower time on ice per game. So great. So now we know as much as we need to know about hockey to understand my talk. And we can go about quantitatively evaluating what Zac Rinaldo proposed in his post-game interview. So to quantitatively evaluate his question, I can then analyze NHL hockey penalty data. This is really fun, and it would be really easy if there was an NHL hockey penalty data set right out there for me to use. Unfortunately, there is no such data set. So I'm going to have to make my own data set. And to do this, I use web scraping. And here I say web scraping is just extracting data from websites that don't have an API that allow you to get it programmatically. So what kind of things do you want to think about when you're starting your first web scraping project? First, you're going to want to know what data do you need. And you're going to want to know what features you should look for in a website. And you're going to want to know what to do with the data once you get it. And so to figure out what data you need, you're going to use your brain. And this is not a Python module called brain. This is your actual brain in your head. And this is a really important step. You want to be able to answer any question you want. You don't want to say, oh, there's a data set over there. What question can I answer with that data set? You want to say, I want to answer this question. So what data do I need to answer this question? And then to determine what features you want in the website, I guess you also want to use your brain there. But you're going to look more at the source codes of the website. And then to use the data, you can use the request library to actually get the web page. And then Beautiful Soup, or if you have a different favorite HTML parser to extract the data from the website. And pandas is a great tool for analyzing data in Python. And then stats models has the statistical methods that you need for your analysis. So when you're designing your experiment, you're going to want to think of 3 questions. First, what is the question that you want to answer? I want to answer, when is it good to be bad? What data will you need to answer that question? Well, I'm going to need penalty data, game data, probably some team data and some player data. What data is available? So there's lots of different sports websites out there that have an abundance of hockey data on them. And then what features should you look for in a website? And there's 2 main features, I think. First, you want to know, is it easy to automate moving from page to page? Chances are all of your data is not going to be on a single static page, and so you're going to want to move around to collect all of your data. And then secondly, you want to know, is the data easy to parse from the source code? And to do that, you can just look at the source code. So I was able to find play-by-play game recaps for all NHL hockey games, or most NHL hockey games, since the 2002-2003 season. And the URL of these hockey games was such that there was a constant, followed by a season indicator, followed by another constant that just meant regular season, and then just the game in the season. So there's a total of 1,230 games per season. So you can kind of see that it will be easy to automate moving through these pages. So you just loop through all the seasons, loop through all the games, and then you've collected the contents of each of these pages, and all of a sudden you've downloaded 10,000 hockey games onto your computer. And then you want to know, is the data easy to parse from the source code? So you might want to think about this before you download 10,000 hockey games to your computer. But, maybe you just like having hockey game recaps on your computer. So I look at the recap in the browser. It looks like tables embedded in tables embedded in tables. Oh, I look at the source code. It's tables embedded in tables embedded in tables. Perfect. So I'm going to decide to use Beautiful Soup, which is a a standard HTML parsing library that's available. It can pull out specific elements that you tell it to. And so I tried that with my 10,000 hockey games. And unfortunately, since the information here is added in real time, there's a lot of really bad formatting to these game recaps. It's so bad that a lot of times Beautiful Soup won't recognize them as valid HTML. So I was only getting about half of my games to parse with my Beautiful Soup. And so I had to build my own parser, which hopefully for your first web scraping project, you will not have to build your own parser. But it wasn't actually that difficult. Just again, by looking at the source code, I could find that whenever there was this line that had PENL in it, that indicated penalty, and most of the details were in the next line, and some of the timing details were in the lines above it. So I could just look for that line and then get the information from the lines around it. At this point, I was still extracting all the content with Beautiful Soup, and then it was going really, really slowly. So I switched from using Beautiful Soup to extract the text content, and I just started using the LXML parser that Beautiful Soup actually uses, and it sped up my code like 8.5 times. It's amazing. Okay, so I have all of my penalty data. I also got some player data that was from a much better formatted website, so I didn't have to build my own parser for it. So I got penalty information, I got some team information, I got some player information, and I want to be able to put all this information together. So that should be really easy, right? Of course, it's not really easy. When you're using multiple data sources, the data fields might not be named the same. So for example, my play-by-play game recap showed the New Jersey Devils as N.J, whereas the player stats website had it as NJD. And I needed to be able to say that these were the same teams. So I had to build in a dictionary that corresponded these to each other. And then also I was using the player stats page to put in those specific time on ice and penalty and minutes per game about each player. But the player stats page gave players by their first name and their last name and the teams they played for that season. And the play-by-plays, they gave the number and their last name and their team. So as long as there was only one guy on the same team, as long as everybody on the team had a unique last name, it wouldn't be very difficult to match them up. Unfortunately, there were a few cases where there were players with the same last name on the same team, and I refer to this as the brother problem. And to get around this, I found all the instances where brothers, whether or not they were real brothers or not, were on the same team for a given season, and I made a little dictionary that matched up first name to number. And so before I started matching up all the data, I checked to see if that last name was in my dictionary, and if it was, then I could sort out which player it actually was. And if it wasn't, it just passed straight through, and it was pretty fast. And second, I was looking at game data that went all the way back to 2008. I could have been looking earlier, and teams change names over time. So if I was interested in the Anaheim Ducks before 2006, they were known as the Mighty Ducks of Anaheim. And I had to be able to tell that these were the same teams. The Arizona Coyotes is fun. They're currently the Arizona Coyotes. Before that, they were the Phoenix Coyotes. Before that, they were the Winnipeg Jets. Now there's new Winnipeg Jets that used to be the Atlanta Thrashers. It's really quite easy to get mixed up here. And then sometimes you have more detail in your data than you really care about. When I was looking at my penalty names that I got, there were 113 distinct penalty names from these 8 seasons worth of data. And I was able to reduce these into 8 different penalty types. Sometimes it was just a matter of, in a different season, a penalty was called something else. So one year it was high stick, and the next year it was high sticking. But they really mean the same thing. So I just mapped each of these distinct penalty names to these 8 different penalty types. So physical foul, and that's what we're most interested in for this talk, that's those injurious penalties. So the boarding or elbowing or kneeing or headbutting. Stick infractions is when you use your stick inappropriately. So like you high stick someone in the face, or you hook them, or you cross-check them. And delay of game penalties are super boring. And altercation, that's probably what most people think of as penalties. That's where everybody's fighting. I think it would be really fun to look at the altercation penalties. I have not quite figured out how to do it with my current data set because you can't fight yourself, so there's always going to be an offsetting penalty from the other team. But again, for this analysis, we're looking at the physical foul penalties. So now you got all your data, you combined it, you cleaned it all up, and now you want to analyze your data. So for me, I was looking to see how some of these features corresponded to various outcomes of the game. But your analysis could be different. Maybe you just want to do some data visualization, or maybe you want to make a predictive model or something. But I'm looking at the effects of some of these features on some outcomes. And so I had to come up with outcomes. These are just 3 outcomes that I came up with. There could be plenty more. So first one is next goal. So this is saying, does the team that got the penalty score the next goal? The second one is there a positive change? So is the final state of the game better than when you took the penalty? Like, are you losing when you took the penalty and then you end up winning the game? And then the third one I looked at was score differential. So what's the difference in score at the time of the penalty versus the difference in the score at the time of the game? So next goal is really an immediate outcome of the penalty, immediate effects of the penalty. Positive change and score differential are more long-term effects within the game, at least. And next goal and positive change are both binary outcomes, and score differential is a continuous outcome. So to look at these outcomes, I used logistic regression for next goal and positive change, and then linear regression for score differential. So for the next goal and positive change, I'm looking at how do the features relate to the probability that those outcomes happen. Whereas for the score differential, I'm looking at how do those features actually relate to the value of the score differential. And so what are the covariate? What are these features that I'm including? Well, obviously I'm including this physical foul indicator, and then I also have included a home team indicator, some indicators for the strength of your team. I use win percentage. The strength of your opponent, I used opponent win percentage. And then I have some player strength. So I included the penalized player strength of time on ice and penalty in minutes per game, because if these are dirty plays where the player is going to either get ejected or going to be penalized for a long period of time, maybe there's an effect of losing him, either a positive or a negative effect. And then similarly with the drawing player strength. So if you're not familiar with hockey penalty terms, say your penalty is tripping, the tripper is the penalized player, and the trippee is the guy who drew the penalty. So we are also including the drawing player strength because oftentimes in these physical fouls there is an injury, and so maybe there's a benefit to removing one of the other team's good players from the game. And so these are the features that I'm going to include in my regressions. And I wanted to make sure these features were there for all the penalties. So I had a total of 91,000 penalties from my 8 seasons of data. When I filtered by drawn by information, there were 83,000 left. And then after I filtered for next goal scored, there were 77,000 left. So I imported my data set into a pandas data frame. if you had found all of the data you wanted on a single HTML table, you could have skipped all that previous stuff and imported your HTML table directly into pandas. So that's pretty cool, but then you'd miss out on all the other fun. And so when you import your information, you can also tell pandas what kind of data it is. So it will automatically think of numeric characters as numbers, but like season, I don't want it to think of that as a number, because really it's not a number, it's a string. And same with Boolean values. So those are usually indicated by ones or zeros in my data set, and so I made those into Boolean values. And then secondly, you want to make sure that all of your column names have no spaces in them, and that will make including them in your stats models formulas much simpler. And so for the logistic regression, I use the stats models logit. And so this is a really simple model for next goal, where I'm only including the physical foul indicator and the home team indicator. And physical foul was not significantly related to the probability of scoring the next goal. The confidence interval spans 0, whereas home team did seem to have a positive effect on the probability of scoring the next goal. And when I included all the other features, physical foul remained not a significant indicator of the next goal probability, but win percentage and opponent win percentage, so how good you are compared to your opponents, was also significantly related. And similarly with positive change, so this includes all of those features. And again, only home team win percentage and opponents win percentage were significantly related to the positive, or to the probability of having a positive change in the game. For linear regression, I use the stats model's OLS model. And again, I have my formula written there at the top. And then for the linear regression, similarly, foul, being a physical foul was not a indicator of your final score differential, but home team win percentage and opponents win percentage all did seem to be relevant to that value. And interestingly enough, the only player value that was significant in any of the models was the drawn by penalty minutes per game, which was positively associated with this score differential. So what that kind of means is that if you take out a guy on the other team who gets a lot of penalties, so that means he's probably either their enforcer or a little bit rougher of a guy, that's going to have a positive outcome on your team, maybe because he's not going to be out there later on to mess with your own teammates, which I thought was kind of an interesting outcome. So when is it good to be bad? Well, it's good to be bad when you have a better record than your opponent and when you are the home team. These are really boring answers. Physical foul penalty had absolutely nothing to do with it. And these are all really kind of obvious. Of course, if you're better than the other team, you're going to do better in these positive outcomes. So how was Zac Rinaldo so wrong when he said this? And this is kind of an interesting question to think about because I have done this analysis previously using older data, and not like a lot older data, like shifted 5 years maybe, or starting with 2002. And when I used that data set, there actually was a positive impact, or getting the physical foul penalty did have a significant role in increasing your probability for those positive changes or scoring the next goal. And so I think it's like a timing issue where it sort of signifies the change in the NHL landscape of we don't really want to be fighting, we want to be safer. Definitely all these penalties are decreasing in frequency over every season that I looked at them. And so maybe Zac Rinaldo is just playing in the wrong era. So with that, I have to thank Seattle Pie Ladies, who always encourage me to do crazy things like talk at PyCon, and my employer for helping me be here. And here's a little epilogue you can read. We looked at what was the effect of taking a penalty for your team. We didn't really look at your own personal career. And that's it.
Okay, thanks so much. We've got a couple minutes left if anyone has any questions. If you don't mind coming back here to speak at the microphone so everybody can hear what you're asking. All right, then feel free to talk to Wendy after the talk if you were too nervous to come up here. And thanks.
I got one.
Oh, there we go.
Sorry, I didn't know it'd be so loud. So through this analysis, could you figure out by doing similar analysis if maybe certain teams react worse or better against enforcers? Like maybe there's a team that can't handle the pressure. Would you be able to figure that out with this type of analysis, or did you try?
So I didn't really look to see if there was a specific team effect, and it might be difficult to tease out whether they could handle the pressure more, or maybe they had a better power play unit or a worse penalty kill unit or something like that. There'd probably be a lot of factors that go into how you can deal with this type of pressure. But that would be interesting to look at.
Yeah. Thank you.
Hi. A lot of these web scraping techniques or problems involve a lot of sort of one-off solutions to weird formatting issues. Do you have a sense for what we can do to make maybe general tools so that you're not always solving these little problems from scratch every time?
Oh. That would be really great.
Right? Wouldn't it?
Well, obviously, from like a starting a new project perspective, I would not look for a data set that is inputted on the fly. Maybe look for a data set that's on like a more professional level website where they might have had professional people designing their how the data occurs on their website, and not hockey fans who are doing it while they're drinking beer and watching hockey. But I don't know if there's like a way to like force formatting. It's hard because like the browsers will show anything, so they don't care. And the people who put the data up there maybe don't want you to be taking their data off. So it'd be hard to maybe convince somebody that this formatting is really required.
Thanks.
Can we apply this same analysis to crappy beer league hockey?
So that's a good question. That's a really good question. And I think that it would not work as well because there's a lot more chance involved because the skill is not as much. This is anecdotal evidence from me watching beer league hockey games.
I appreciate the honest answer.
Is that in beer league hockey games, sometimes a team plays better when they're down a man because it's like more intense and they're like, whoa, we really have to do something good here, versus when they have other guys on the ice, they're just kind of like lackadaisical.
Hi.
Hello.
I was wondering if you ever use mechanized for data scraping too, because I hear everybody talking about how Beautiful Soup is the best, but I use mechanized because I can submit forms while I'm scraping data. And I thought maybe Beautiful Soup has like better, like more usable, is somehow more usable than that, but I haven't used it.
So I have not used mechanized, and I might look at it. I honestly chose Beautiful Soup because it was like my first time trying web scraping, and I'd heard so much about it, and there are lots of tutorials out there on it that I could look at, and so that was my decision-making process.
Well, thank you.
Okay, thank you, Wendy. Thanks, everyone, for your questions.